This is Mrs. Zappia with the answer key for the practice test for Grade 7, Module 5, Topics C and D, Lessons 13 through 23. The dot plots show the number of miles run by members of two track teams during one day. A sample of size 25 was taken. The population was middle school track teams. That means that each dot represents the average of 25 people, how many miles they ran. There are 24 dots in each graph, and Team A is symmetrical. That means that the data on the left side mirrors the data on the right side. Okay, that's called symmetrical. Skewed, over here for Team B. Notice that there is very little data down here at the end, and most of the data is at the other end. That is called skewed. So, making an inference about the two teams. The shape of Team B data is skewed. The center of the data. Now, I want to make sure that you know when you're looking at the center of the data. Sometimes you're talking about the physical center. Sometimes you're talking about the average. And you also might be talking about the median or the mode. So let's go over that. When you talk about the actual center, that is called the median. And in this case, there are 24 dots. So we spread them equally, 12 dots and 12 dots. And then the middle of those two places would be the center. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 dots on the left and 12 dots on the right. The center of the data would be right here, which would be the average of those two numbers. Well, the halfway between 5 and 5 is 5. So the center is 5. Do you know how to find the average number of miles run? Now remember that the average is called the mean, and that would be the total miles divided by the number of days. So if you wanted to calculate that, you would add these numbers together. You would add 2.5 plus 3 plus 3.5 plus 3.5 plus 4 plus 4 plus 4.5, etc. You would get the total number of miles, and that adds up on Team A over here. It adds up to 106.5. On Team B, it adds up to 117 miles. And then you would divide by the number of days, which in this case is the number of dots, and you would divide by 24. So make sure that you know how to calculate the average, which is the mean, and the center of data, which is the median. Also, make sure that you understand the mode. The mode is the most in that set of data. In Team A, the mode would be shared by these three numbers, and the mode in Team B is 5.5. So make sure you understand the center is the median, the average is the mean, and the mode is the tallest, or the most frequent answer. Make sure that you can do all of those. Okay, the team that runs the most miles. The team that runs the most miles is Team B, and if you continue adding these as we did before, adding 4.5 plus 4.5 plus 5 plus 5 plus 5 plus 5, etc., that will tell you how many miles were run in one day by that team, the average number for the 25 samples. Predict how Team A dot plot would look differently in the sample size had been 5 students instead of 25 students. Now this is a level 4 question, so you want to make sure that you understand how the sample size affects your plot. When you have a smaller sample size, that means you will have a greater variability. A greater variability means that you will have a larger range from the left to the right on your dot plot. So you'll have a larger range, and that means that your data will be more spread out. If the sample size is bigger, say for example, we asked 30 or 40 students, how many miles did you run today? You will expect with a bigger sample size that there will be less variability. and the data would be more clustered. So less variability would mean a smaller range from left to right, while a larger range, that means the greater variability. The double dot plot shows the number of magazine subscriptions from two doctors' offices for the past 15 years. Find the MAD for Office A and the mean. You may use the chart below to help you calculate the MAD. So it's already calculated for Office B. Office A, what you'll be adding, this dot represents 3, so you'll add 3, let's use a highlighter, plus 4, plus 4, plus 5, plus 5, plus 5, plus 6, plus 6, plus 6, etc. Add all of those together and you get 240. Then you divide by the number of data points. So you count the data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. And there are 15 data points. You divide, and if you don't get a whole number, round to the nearest tenth. In this case, you get 6. So the mean number, or the average number of miles run, is 6 per day. Then the MAD. Remember, when you're calculating the MAD, you can use this chart to help you organize your data. Your data is the data points from here. So you would go ahead and write those down, 3, 4, 4, etc. Then you're subtracting from the mean. You always want the positive value. So remember, when you're subtracting, to start with the larger number. If you use a calculator and don't start with the larger number, remember to just drop the negative sign and use the absolute value. So we do all of the subtraction. The mean of 6 minus the data point 3. The mean of 6 minus the data point 4. We do all of that subtraction and we end up with all of our distances from the mean. Then you add those distances together and you get 20. You divide by how many data points there are. There are 15 data points on the dot plot and 15 distances that we subtracted. You divide and round your answer to the nearest tenth. So we have a MAD of 1.3. Question A. Comparing the means of the two teams. Who has the higher mean and by how much? So we have our data table. We have the mean of 6 and the mean of 3. Office A has the higher mean and by 3 subscriptions. So you take the mean of A, subtract the mean of B, and this will be the difference, or to find out how much higher. Question B. How many MADs separate the two sample means? So we have the difference in the means divided by the larger MAD. If you want to memorize this, it will be on the test. The difference in the mean was calculated right up here from the previous problem. Then you want to look at your two MADs and pick the larger of the two MADs. 1.3 is larger. Do the division, 3 divided by 1.3. You can round to the nearest tenth, and we get 2.3 for our answer. The question was, how many MADs separate the two sample means? And the answer is 2.3. Remember that a number that's greater than 2 means that the populations have a meaningful difference. A difference in MADs of less than 2 means that the populations are similar. The small difference can be attributed to the sample variance. Recall that if the number of MADs in the difference of the two means is greater than or equal to 2, it will be reasonable to think that the population means are different. Based on your calculations, is the difference meaningful? So our difference was 2.3. Since this is greater than or equal to 2, this is a meaningful difference. The means are separated by more than 2 MADs, which is the mean absolute deviation. Based on your answer of the previous problem, which doctor's office would have the largest variety of magazine subscriptions, or would it be about the same? Office A has the largest mean. And remember that it is a meaningful difference because it was more than 2 MADs. If it was less than 2, we would say the difference is insignificant. Question C. If you were selling magazine subscriptions, would you approach Dr. Office A or Dr. Office B to buy a subscription? Explain your reasoning. So your answers will vary, and there may not be exactly one correct answer, but your choice of office needs to be backed up with a justifiable reason. So here are some thoughts. First, you could go to Office B. Office A already has a lot of subscriptions and might be unlikely to buy more. If you said go to Office A, you need a reason. If I said go to Office A, having a variety of subscriptions seems important to them. Magazines in the office has value, or they wouldn't have them. They might be likely to purchase more. So you just make sure and explain your choice. That concludes our review for the test.